In this video, I'm going to teach you how to find the equation of a tangent line at a point. If you appreciate the content, please give it a like. A tangent line is a line that intersects the function at a single point, like this blue line. So we need to learn how to find the equation of a line like this. At the beginning of the unit, we learned that the derivative of a function is the slope of the function at a point. Well, more specifically, that's the slope of the tangent line at a point. So when we talk about the slope of the line tangent to f at x equals a, we are talking about f prime at a. So the derivative at a point is the slope of the tangent line at that point. For example, if I want to find the slope of this function f of x at x equals 2, I need to find f prime at 2. So first, let's find f prime. We will take the derivative term by term. Using the power rule, the 2 multiplies the 3 in the front to make 6. We reduce the exponent by 1, so we have 6x. The derivative of 2x is just 2, and the derivative of a constant is 0. So this is f prime. The derivative is a slope-generating machine. This will give us the slope of f at any point, including 2. All we have to do is evaluate f prime at 2, which in this case will be 6 times 2 plus 2. F prime at 2 is 12 plus 2, or 14. And that's it. The slope of the line tangent to f at x equals 2 is 14. Whenever we need to write the equation of a line, we love to use point-slope form because all we need is a point and the slope. Given a point x1, y1 and slope m, the equation of a line is given by y minus y1 is equal to the slope times x minus x1. In calculus, the slope is given by the derivative. So instead of writing m, I'm going to write f prime. I'm going to fill this in a second. They are asking us to write the equation of the line tangent to f at x equals a. So instead of putting x1, y1, I'm going to put a right here. This is the location of the point of tangency. So this is where we need to evaluate the slope. So the slope will be f prime at a. I'm just going to put b here, but that's just the output value that goes with this particular input value. With this in mind, the equation of the line tangent to the graph of f at x equals a, using point-slope form, will be y minus b is equal to the slope, which is f prime at a, times x minus a. Let's try out this example. To find the equation of the tangent line at x equals 3, we're going to need a point and the slope. The point is going to be 3 comma something. They're giving us the x value. So we need to find the y value, the output value that goes with this input value. Well, to find the y value, you simply plug in the x value. So we need to find f at 3. So that's just going to be 3 times 3 squared plus 2 times 3 minus 3. Let's see, that's 3 times 9 plus 2 times 3 minus 3. That's 27 plus 6 minus 3. That is 33 minus 3, which is 30. So the point we were looking for is 3 comma 30. Now we need to find the slope at x equals 3. In other words, f prime at 3. First we need to find f prime. So f prime of x will be, I think we already did this, but 2 times 3 is 6. the derivative of 2x is 2, and the derivative of a constant is 0. So this is f prime, and we need to find f prime at 3. So f prime at 3 will be 6 times 3 plus 2. That's 18 plus 2. You know what? I'm just going to go ahead and write 20. So that's the slope. Once you have a point and the slope, you can write the equation of the tangent line. In point-slope form, it will be y minus y, which is y minus 30, is equal to the slope, so that's 20, times x minus x, so x minus 3. And that's it. This concept of finding the equation of the tangent line is going to come up over and over and over again throughout AP Calculus, so learn it well. I encourage you to pause the video and try this one on your own. So I'm going to just assume that you did that. To find the equation of the tangent line, we're going to need a point and the slope. To find the point at x equals 3, they're telling us that the x value is 3. So we just need to find the y value that goes with this x value. So to find the point, we need to do f at pi over 3 to get that output value. So that's going to be 4 times pi over 3 minus the tangent of pi over 3. Hopefully you memorized these 9 trig values long ago, including the fact that the tangent of pi over 3 is radical 3. Even though this has 2 terms to it, this expression is the output value that goes with this input value. In other words, the point that we are looking for is the point pi over 3, comma, 4 pi over 3 minus radical 3. Now we need to find the slope. To find the point, we had to do f at pi over 3. For the slope, we need to do f prime at pi over 3. Which means first we need f prime. The derivative of 4x is 4, and the derivative of tangent is secant squared. That's a memorized rule. So we have to evaluate this at pi over 3 to get the slope. So that's 4 minus secant squared pi over 3. Secant is the reciprocal of cosine. We know the cosine of pi over 3 is 1/2. Cosine and secant are reciprocals of each other. So if the cosine of pi over 3 is 1/2, then the secant of pi over 3 is 2 over 1, or simply 2. But what we have here is secant squared. So secant squared of pi over 3 will be 2 squared, which is 4. You do all of this in your head. That's why I put it in this thought bubble. What you write down is f prime at pi over 3 is equal to 4 minus, well, 4, which is equal to 0. The slope is 0. That means we must be dealing with a horizontal tangent line. Now that we have the point and the slope, we can write the equation of the tangent line, which will be y minus y. Now be careful, if I just write 4 pi over 3 minus radical 3 and I move on, this is wrong and I'm going to lose the point. Because we are subtracting and there's more than one term, we either need to write this in parentheses, which is what I normally do, or you need to distribute this minus sign and turn this into a plus. So I'm going to write it like this, but just to be clear, another option would be to write it like this. So that's y minus y is equal to the slope, which is 0, times x minus x. So that's x minus pi over 3. Alright, it feels silly to leave it like this because multiplying by 0 is just 0. So this whole side is really gone. So it makes more sense to wipe this out and then move this to the other side. So we would get y equals 4 pi over 3 minus radical 3. And if this was a multiple choice question, this is what you would most likely see. But what we had right here, including the 0, is also a full credit answer on a free response question. Pause the video and try this one on your own. To find the equation of the tangent line to f at x equals 4, we're going to need a point and the slope. They're giving us the input value of the point. To find the output value, we need to do f at 4. Ultimately, to find the slope, we're going to need f prime at 4. So just get used to that. We're going to need f at 4 and f prime at 4. The first one gives us the output value for the point, and the second one gives us the slope. But back to the blue. F at 4 is going to be 5 over 4 minus 1, which is 5 over 3. That means the point that we needed was 4, 5 over 3. For the slope, we need f prime. So we could do the quotient rule because we have 5 over x minus 1, but I don't recommend that. I was going to suggest a rewrite of f of x equals 5 times x minus 1 to the negative 1 power. But this is a function inside of a function, which requires something called the chain rule, which we will learn soon, but we haven't learned yet. So we are going to go ahead and do the quotient rule. But by the time you get to the test, we're going to know the chain rule, and that's really how you would do it. But the quotient rule says we find the derivative of a quotient by doing low d high less high d low. Draw the line, and down below, the bottom squared will go, our little poem. So again, it starts off low d high. That means the denominator, which is x minus 1, and then d high means the derivative of the numerator. But the derivative of a constant is 0. So that's going to wipe this out. But this is low d high. Less means subtraction. So low d high less, and next it is high d low. High means the numerator, and d low means the derivative of the denominator. The derivative of x is 1, and then the derivative of negative 1 is 0, so we're left with just the 1. So this is low d high less high d low. Draw the line, and down below, the bottom squared will go. So let's definitely rewrite this. Actually, I'm going to go ahead and do f prime at 4. I think you can follow that this portion right here is gone because times 0. So in the numerator, we just have the negative 5. And plugging in 4 for x, that's going to be 4 minus 1 squared. So this is going to simplify down. 4 minus 1 is 3, squared is 9. So the slope is negative 5/9. Now that we have a point and the slope, we can write the equation of the tangent line. It goes y minus y, so y minus 5/3 is equal to the slope, negative 5/9, times x minus x, so x minus 4. And that's it. Number 14, find the equation of the line tangent to the graph y equals sine x minus cosine x at the point 0, 1. You may give your answer in any form. You know that to find the equation of the tangent line, we need a point and the slope. They were kind enough to give us the whole point, so that part of the work is done. We can move on to finding the slope. To find the slope, we're going to need f prime, well, y prime, and we're going to find that by taking the derivative term by term. The derivative of sine x is cosine x. And then I see that minus there, which I'm going to put there temporarily because the derivative of cosine x is negative sine x. I'm going to put this temporarily, negative sine x. But of course, minus a negative is a positive. So really, we're going to put plus sine x. So this is y prime. The slope at the point 0, 1 is going to be y prime at 0. We are evaluating at the x value of the point of tangency. So that's going to be the cosine of 0 plus the sine of 0. Cosine is the x value on the unit circle. And at 0 radians, right here at the starting position, the x value is 1, because the radius on a unit circle is 1. So cosine of 0 is 1. Hopefully you definitely knew that. Sine is the y value, which is 0. So the sine of 0 is 0. So the slope is 1. We can go ahead and write the equation of that tangent line. Keep an eye on the point that they gave us. So y minus y, that's y minus 1, is equal to the slope times x minus x. This is a full credit answer. It feels a little bit silly to leave it like this because there's so much that can be simplified. Disregarding the 0 and the 1, this is y minus 1 is equal to x. And if we were to add 1 to both sides, we would get y is equal to x plus 1. So this is more likely what you would see as an option on a multiple choice question. Number 15 is related to what we just found. Which of the following is equivalent to the linear equation you wrote above? So I'm noticing that in all of these answers, they have the x and the y on the same side, and they've written it so that the x is positive. So I'm going to rewrite, one of the equations that we have, but I'm going to do it putting the x and the y on the same side, leaving the x positive. So kind of go back here with me. The x is already positive, so I'm going to leave that over there. To move the y over with it the way they have, I'm going to subtract y from both sides. So that would give me negative 1 is equal to x minus y. In other words, x minus y equals negative 1. There it is. The answer is C. Problem number 16 is a common type of problem that you're going to find on your school test and on the AP exam in May. I think of this as a K problem for obvious reasons, and I'm going to teach you a trick for how to do it. So the line y equals negative 2x plus 3 is tangent to the graph of y equals kx squared, where k is an unknown constant. Find the value of k. The trick is to organize your work into a T-chart like this. We are going to set up a system of equations. On the left side, we're going to set up an equation of the form y equals y. And on the right side, our equation will be of the form y prime equals y prime. The left side is the easiest because they gave us two different forms of y. We just need to set these equal to each other. So I'm going to put kx squared equals negative 2x plus 3. That's my y equals y equation. Now it's time for the y prime equals y prime equation. Simply take the derivative of both sides of the blue equation. Remember, k is a constant, so treat that as a number like 5. So, taking the derivative of the left side using the power rule, we would bring this 2 down into the front and multiply by that k. So that's going to be 2kx as we reduce the exponent by 1. So 2kx equals, we take the derivative of the right hand side as well. The derivative of negative 2x is simply negative 2, and the derivative of 3 is 0. So that's it for the right hand side. What we have here is a system of 2 equations and 2 unknowns. So we know how to solve this from Algebra 2. Start from the simpler side. Since ultimately we need to find the value of k, start by isolating the x. So I'm going to divide both sides by 2. Let's get that out of the way. So we have kx is equal to negative 1. Now I'm going to divide by k. So x is equal to negative 1 over k. Now we substitute this expression, which is equivalent to x, in for x in the blue equation. So we're going to have k times negative 1 over k squared is equal to negative 2 times negative 1 over k plus 3. So let's go ahead and square this. So we will have k times, the negative is going to go away as we square this. So this will be 1 over k squared. A negative times a negative is a positive. So this will be 2 over k plus 3. This k is going to cancel out one of these k's. So on the left side, we are going to have 1 over k is equal to, should we go ahead and subtract these? I'm going to go ahead and subtract 2 over k from both sides. So minus 2 over k is equal to 3. We can easily combine fractions that have like denominators like this by just putting the numerators together. So 1 minus 2 is negative 1. So this is negative 1 over k is equal to 3. We can, you could think of this as cross multiplying. I know kids love to cross multiply, but what I like to do is take the reciprocal of both sides, which is another valid move. I'm running out of space, but if I do the reciprocal over here, I'm going to have negative k over 1, or simply negative k, and the reciprocal on the right hand side would be 1 over 3. I'm just going to go into the red area now. Obviously, to get k by itself, we just need to multiply both sides by the negative 1. So k is equal to negative 1/3. Kabam! Super common question. Practice it. Last one, number 17. If the line tangent to y equals f of x at the point negative 3, 8 passes through the point negative 2, 5, then which of these statements is true? We can eliminate most of these options immediately. All of the answer choices pertain to f prime at some point, the slope of the curve at a point. Which point? The point of tangency. So which of these 2 points mentioned in the problem is the actual point of tangency for the tangent line? Well, reading again, it says, if the line tangent to y equals f of x at the point negative 3, 8. Aha! This is the point of tangency, not this. So, the slope of the curve at a point means f prime at this point, f prime at negative 3, not negative 2. So, we can forget about options A and B and E. So it just comes down to these two. Now remember, f prime is the slope of the tangent line. And they have given us 2 points on the tangent line. So we can easily calculate the slope using our Algebra 1 skills. Really, so it's just y minus y over x minus x. You know what I mean? So here we go, y minus y. So that's going to be 5 minus 8 over x minus x. So negative 2 minus negative 3, negative 2 plus 3. That's going to be negative 3 over 1, which is negative 3. So the slope of f at negative 3 is negative 3. That's how we know the answer is D. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.